The basically of two Kirchhoff law are first, yeah, Kirchhoff current law or KCL, yeah, based on principle of conservation of electric charge. Second one, Kirchhoff voltage law or KVL, based on principle of conservation of energy. Uh, we have two of Kirchhoff law, yeah, KCL and KVL on the DC circuit, yeah. About current, about voltage. Yeah, no, the first law is like this one, yeah. This law is also called Kirchhoff first law, yeah. Kirchhoff point rule, yeah. Kirchhoff junction rule or nodal rule on the Kirchhoff first law, yeah. This is about current, yeah. The current entering any junction, yeah. When we have a junction, yeah, junction from some of lines, yeah. The current entering any junction is equal to the current leaving that junction, or in this case is entering is I2, I3, and leaving is I1 and I4. Yeah. The current entering any junction is equal to the current leaving that junction. Yeah. Or actually, total I equals to 0. Yeah. I input minus I output equals to 0. I entering junction, yeah, in this case is I2 and I3, yeah, equals to I leaving from this junction, I1 and I4. Yeah, so this is I1 plus I4 equals to I2 plus I3. Yeah, that's it. The second one, Kirchhoff voltage law or KVL. This law is also called Kirchhoff second law, Kirchhoff loop. Ya, this is loop ya, ketutup sama ini. Loop rule, L-U-U-P rule. Ya. And Kirchhoff second rule. Ya. Yeah, when we have a loop or closed circuit, or ini tertutup ya, bukan dekat. Rangkaian tertutup. Ini kan tertutup, tidak ada yang terbuka ya. The sum of all voltage run in the loop is equals to 0. It means V1 plus V2 plus V3 minus V4. Ini minus because they have minus here. This is same thing, 0 equals to 0. Or total V, yeah, total V equals to I total R. So actually, we back into Ohm's law, yeah, V equals to IR. But because voltage is not only one, yeah, sum of voltage, so this is total voltage. And also R, yeah, because sum of total resistance. So total voltage, total VEMF, yeah, equals to I times total resistance. Yeah, that's it. Okay. Only this year about material, about theoretical of Kirchhoff current law and Kirchhoff voltage law. Okay, now we see about apa namanya question. Yeah. Wait. Okay. We see on the left is about theory, and we see on the right about question. Okay, let me try to solve some question here. Yeah. State Kirchhoff first law. This is intermediate level. Yeah. State Kirchhoff first law. This one. Yeah. The current entering any junction is equal to the current leaving that junction. Kita bisa mungkin copy paste ini aja ya. Nah ini Okay. Hmm. Hmm. The current entering any junction, yeah, equals to the current leaving on that junction. Yeah. Yeah, that's it. Kirchhoff first law. Yeah. Okay. Question 2. Kirchhoff first law express the conservation of an important physical quantity. Yeah. Name the quantity of this conserve. It about apa namanya KCL. Nah, based on principle of conservation of electric charge. Yeah. Based on principle conservation of electric charge. Yeah. That's it. Ini yang constant adalah electric charge. Yeah. Yeah. Because they relationship in current. Yeah. Currents mean charge flowing. Yeah. Currents mean charge flowing. So they have conserve in electric charge. Yeah. Okay. Now other question. Yeah. Number 3. Yeah. Determine the current I in each of the circuit below. Yeah. On A question, we have a current entering this junction. Yeah, this is the junction. Is I, and current living on this junction is 2 and 1. So I in is in here is same thing with total between 2 and 1. Yeah. So I equals 2 plus 1.0, yeah, equals 3 ampere. 3.0 ampere. That's it. This is still easy, yeah. Still easy. Okay, question B. Yeah, question B. We have current entering this junction is 0.5 and 0.7 ampere. So I is in here, ya, ya kita jumlahkan aja sama kayak ini ya. Same thing with this one. This is I equals to 5.0 plus 0.7. 0.5 ya. 0.5 plus 0.7. Yeah, this is equals to 1.2, yeah, ampere. This. Easy, yeah. Okay. The third one is the currents, yeah, entering the junction is I plus 2 and leaving is 4.0 and 0.5. So it means like ini kalau Bapak tulis ini sama dengan I plus 2.0 equals ya 4.0 ya plus 0.5. Ya, ini kita lihat. So I equals 4.5 minus 2.0. This is equals kita dapat ini adalah 2.5 ampere. That's it. Seperti itu ya, guys. Continue to number 4 ya. I scroll up. Okay. Several identical cells are used to connect it up circuit. Each cell has EMF 1.5 volt. Determine the total EMF for the following combination of cell. This is 1.5 plus 1.5 because the polarity is one direction. So in here, this is EMF or E equals to 1.5 plus 1.5. This is equals to 3.0 volt. Okay, what about the second one, the B1? This is different. I copy from this. This is E 1.5 plus 1.5 plus again 1.5 but minus 1.5. So equals to 3.0 volt also. This is plus and this is minus. Plus 1.5 plus 1.5 plus 1.5 minus 1.5. So this has become to 0. So same thing with E equals to 1.5 plus 1.5 equals to 3.0 volt. That's it. Okay, what about C? C is in opposite position, in opposite polarity. So it means this is negative. 1.5 minus 1.5 equals to 0. 0 volt. Okay, that's it. Use Kirchhoff's second law to calculate the current I in the circuit shown below. We use the Kirchhoff's voltage law or second law. This total VEMF equals to IR. Also, we can say if we use like the direction of current. Aduh. Sorry. Gini aja deh. Kita we use Kirchhoff's second law is voltage 1 plus voltage 2 plus voltage 3 equals to 0. Because this is only 3 on the 10, on the 20, and also 6 pole they have. So V1 is I times R, yeah, 10. This is V1. Yeah. And V2, yeah, is still I, yeah, but times with 20. And we see this is coming from negative because the short one, yeah, is negative. This is negative and this is positive, yeah. Also this is negative and this is positive. So the sign here, yeah, is negative 6.0. So equals to 0. Okay. In other equation, this is something with 10i plus 20i, yeah, equals to 6.0. Okay, in other equation, 30i equals to 6.0, yeah, or I equals to 6 divided by 30, 0.2, yeah, m per, yeah, that's it. Okay, I hope you understand about this one. Yeah, we use this Kirchhoff voltage law or Kirchhoff second law. Okay, if you want to copy, just copy here. Number 6, high level. Yeah, maybe still for Kirchhoff voltage law. Yeah, the diagram shows an electrical circuit. The battery and cell in the circuit may be assumed to have negligible internal resistance. Yeah. Calculate. Question A, the current in the 12 resistor. B, the potential difference across the 68 ohm resistor. Okay. Okay. This is something with number 5 actually, but they have further question. Yeah, like this one. I just copied this. Yeah. Why? Because they have 3 voltage, yeah. Voltage on 68, voltage, oh sorry, this is they have 4 ya. Voltage in this apa namanya, this EMF, ya. And voltage in 12 ohm and also in 6.0 volt. Okay, we start from this, yeah. I need to okay, V1 plus V2 plus V3 plus V4 equals to 0. Okay, V1, let's say from this, yeah, 68. They have I times 68 ohms. Then V2 is in here, yeah. Let's say this is positive, yeah. So positive first, yeah. This is negative, this is positive. So in this context, yeah, here is positive. V2 is 1.5. Then positive again with I times the resistor in 12 ohm. Yeah, this is 1, 2. And negative 6.0 volt. Yeah, this is negative. So equals to 0. After that, yeah, 10.1, sorry, 68I, 68, oh my God. 68I plus 1.5 minus 6. Oh, this is langsung aja 12 ya. 12I, and here is 6 minus 1.5. This is equals to 4.5. Okay, so in here is 68 plus 12, something with 80. 80I. Yes, correct. 80I equals to 6. So I is 6 divided by 80. 0.075 ampere. Ampere. Now this is current in 12 ohm. Also same thing current in 68. Yeah. So when question B, the PD across the 68 resistor, yeah, same thing with we use Ohm's law again. Yeah, that's V equals to IR. Yeah, so V on or total or potential difference in 68 equals to I is 0.075. Yeah, and then times R is 68. Yeah. So V equals to 5.1. Yeah, 5.1 volt. Yeah, that's it. Yeah. I hope you understand. Yeah, about this explanation. Sorry. Number 7. The arrangement below can be used to determine the electromotive force on the test battery. Okay. I think this is also still related with IGCSE. Yeah. This is about potential difference, potential divide, potential divider. Okay, now the supply battery may be a sum to have negligible internal resistance. Okay. The resistance R of the variable resistor is adjusted until R has value 28 ohms. And the current shown by the ammeter is 0. Okay. So that EMF of the test battery is about 1.1 volt. Okay, we need to prove this question. Okay, when we see this value is 28 and this they don't have any current here, so they only have current on here only, yeah. And total resistance is 100 plus 28. I put this number first, 28 ohms here for the resistance variable. Yeah. So total resistance equals to 128. Yeah. They have 5 volt. We can decide current in this circuit. Yeah. In this circuit, let's say this is I. Yeah. I has current as V divided by R. Yeah, directly V divided by R. And V we have 5.0 volt divided by R is R total. Yeah, this is between 100 plus 28. So same thing with I is 5 divided by 128 ohms. Yeah, this is around 5 divided by 128 is equals to 0.039. Yeah, yeah, maybe 0.04. Yeah, if around it 0.04 ampere. Okay, this is current passing on this circuit. Yeah, not passing on the test battery. Yeah, and after this we can test battery by by using formula Ohm's law again. Yeah, that's V equals to IR. By V equals to IR. Yeah, V is E. Yeah, the test battery one. Yeah, E equals to I is 0.04, and then R uh, battery, test battery is, this is connected parallel with R 28, so R is 28. Yeah, we multiplicate between 0.04 times 28. This is around 1.09. Yeah, 1.09. Yeah, something around in 1.1 volt. Yeah. So proof. Because the answer, or the answer is, it's about 1.1 volt. This is also in 1.1 volt. Yeah. So proven. Yeah. I hope you understand about this one. Yeah. This is actually still IGCSE when the talking about potential difference, about potential divider, about Ohm's law. Yeah, I think this is still in IGCSE. On number 8, use Kirchhoff's law to determine the current I1, I2, I3 in the circuit on the right. Wow, how to solve this? Okay, I separate into two loops here. This is loop 1. This is loop 1. Let's say loop 1. And the right one is loop 2. Yeah, we have loop 1 and loop 2. Between loop 1 and loop 2, we have any junction here, that I1 entering the junction and I2 and also I3 leaving on that junction. Yeah. So from this apa namanya junction, we can say I1. Yeah. So I need to change. What about I1? Yeah, equals to I2 plus I3. Yeah. Okay. On this junction. Yeah. I1 is entering. Yeah. I2 and I3 is leaving. Okay, now after this, we see on the loop 1. Yeah. Yeah. Loop 1, we have start from 10. Yeah, this is 10 of I1 plus 20 of I2. Yeah, and then minus 3.0 volt equals to 0. This is about Kirchhoff, yeah. V1 plus V2 minus, yeah, this is minus, yeah, sorry, minus, yeah, minus V 3 volt, yeah, equals to 0. So we can say here, yeah, this is something with 10 I1 plus 20 I2 equals to 3. Uh, on the loop 1. No, on the loop 2. So. On the loop 2, we go to here, yeah. Loop 2, look at this, yeah, on the loop 2. We start from I3. I3, they don't have any resistance there. Yeah. So 0 I3, 0 I3, yeah, there is no resistance here. Yeah. Minus 20 I2, yeah. Y minus, sorry, minus, plus 20 I2, yeah. And then minus 1.5 volt equals to 0. Yeah. Why minus in this? Yeah, because the direction of load is, this is crossing by negative sign. Yeah. So we can say here, yeah, 0 times I3, yeah, 0 times I3 equals to 0. So this case 20 I2, yeah, same thing with 1, oh sorry, ini minus, ya, minus, same thing to 1.5, yeah. Finally we get I2, yeah, and that I2, yeah, equals to 1.5 divided by 20. 1.5 divided 20, this is equals to 0.075 ampere. Okay, finally we get I2 from the loop 1, from the loop 2, yeah. From the loop 2, we get I2. And what about I1 and I2? Yeah. We just substitute I2 in this equation, yeah, in this equation. So from this, yeah, here, this 10 I1, yeah, plus 20 I2, I2 is 0.075 equals 3. So 10I2, sorry, 10I1 plus 20 times 0.07, 1.5, yeah, equals 3.0. So 10I1 equals to 3 minus 1.5 equals 1.5. So I1, I1 equals to 0.15 ampere, yeah, because 1.5 divided by 10. That's it. Finally, we get I1 also, yeah, from substitution I2 into this equation. Now, the last one is we go to find what about I3 from this equation, yeah, from this relationship. I1 equals to I2 plus I3. I1 is 0.15. I2 is 0.075 plus I3. Yeah, I3, I think 0.075, yeah, because 0.15 minus 0.075. I3, we get 0.075 ampere. Okay, that's it. Yeah, I hope you understand what about this. Yeah, this is actually applying of Kirchhoff's second law. Yeah, with Kirchhoff first law. This is Kirchhoff first law, and then in the loop one and loop two is Kirchhoff's second law. Yeah.